Okay, this is the second of a series of videos. We're going to work on reviewing some AC theory vector addition. This goes clear back to first year. And what I'd like to do is take us up to, actually I want not quite that far yet. I want to take us up to lesson 10, and we're going to work on question 32 and 33. And if you look at question 10, lesson 32 and 33, you'll see a 10 Henry inductor in series with a 1500 ohm resistor, right? We're going to add those up, do the math, figure out the impedance, and find the phase angle. But then I'm going to take it one more step. We're going to use that vector addition machine to say, what if that circuit we just looked at was in parallel with a capacitor of 1500 ohms? Right, what would happen then? What we're going to do is find the current in the LR branch, current in this capacitive branch, add the currents together, use Ohm's law. And you're going to say, well, how can I find current if I don't have a voltage source? Well, we're just going to assume some voltage source. And it doesn't matter what voltage we use, because we're going to use that voltage to calculate the current, and then we'll divide that voltage back out when we calculate up the total impedance. So it's an assumed voltage. It's something we did with early on with resistive circuits, then promptly forgot about it because, with a simple resistive circuit, it really isn't that difficult. The formulas are simple and easy to comprehend. But boy, when you get into these complex LCR parallel circuits, then you will be glad to have a simple way to solve these problems, or relatively simpler. All right, so let's solve first. Let's do that 10 Henry inductor and the 1500 ohm resistor in series. So our 1500 ohms is going to be the horizontal part, and the X sub L that goes with that 10 Henry inductor is going to be the vertical part. So X sub L equals 2 pi FL. Substitute what you know, which is 2 times pi times 60 times 10. You'll get something like 3768. 3768, right? It's a little more than twice this 1500, so that my drawing here is not really to scale. If it was to scale, this 1, 2, 3, 4, 5 going sideways, 1, 2.5, or 1500s would actually be a little steeper than that. You can see, so just with a rough, almost to scale drawing, we can see the phase angle is going to be greater than 45 when we're done. So that'll be an assumption we could test, use to test our work later on, make sure we didn't make a mistake somewhere. So we know the vertical part is 3768. We know the horizontal part is 1500, right? We aren't adding multiple vectors right now. We already know those. When we're working back, trying to figure a vector out, given those two values, then we're going to use Pythagorean to figure out what the vector length is, right? The square root of 1500 squared plus 3768 squared. Take the square root, do that on your calculator. Remember, you've always got a pause button on these videos. If I'm talking too fast, hit pause and use your calculator, test my work. 4055.59 or 4056, 4055, whatever it takes. So I'm not going to quibble about an ohm or two over the course of 4,050 of them. So we'll just, 4055 is close enough for now. And the tangent is, or excuse me, the angle is, you're given the opposite and the adjacent. So why don't we use, TOA, SOHCAHTOA? Right? We're looking for the angle. Looking for the angle, knowing the opposite over the adjacent. So if you're looking for the angle, we're going to go, well, basically second tangent, the arc tangent, since we know the two sides of those two sides will give us theta. Tangent of theta is the ratio. The opposite of the tangent function worked on that ratio gives you theta. It's as if you're calculating out that ratio and then going down your trigonometry table in the tangent column until you find approximately that number, then work over to the left and find out the angle. With our calculator, that's mighty simple. We just plug it in. Second tangent 3768 over 1500 equals, you should get an angle about 68.29. Right? Nothing to it. Nothing to it. So there's the first step in our little problem here. We have a 4055 ohm impedance vector at 68.29 degrees lagging. It's inductive. Right? It's important we make note that this is a lagging phase angle. It's an inductive, or you can make a note that it's inductive. Right? It's 68.29 inductive. That's going to be important if we want to add that to a capacitor later on. So now, what if we wanted to add our parallel capacitor to that inductor, resistor, and series branch? Okay, we did the first step, which is like in any combination circuit, we're going to combine the series elements and redraw. So we combined the series elements on the previous worksheet, and we came up with an impedance of 4055 ohms at a theta of 36.98, excuse me, 68.29, 68.29 degrees inductive, right? Inductive. That's important. Then we're going to have a capacitor of 1500 ohms that we're adding to that. So, right, so now to continue on, what we'll have to do is assume a voltage. What kind of a voltage would you like to assume? Well, two easy assumptions would be either 1500 ohms or 4055 ohms. I'm going to choose 1500 volts, right? We're going to figure the current in each branch with a given assumed voltage. I'm going to assume 1500 volts. Why I chose 1500 ought to become apparent pretty quickly. We're going to calculate two currents. I equals E over X sub C. 1500 over 1500. Gosh, that's 1 amp. So my vector number 1 is 1 amp capacitive, right? Vectors have magnitude and direction. I've got 1 amp capacitive. They're parallel. Capacitive vectors are straight up. 1 amp. Right? Why is that? Because our resistive elements, if there were a purely resistive parallel element here, its current would be in phase with the voltage. Eli the Iceman tells me my capacitive currents are vertical up, my inductive currents will be vertical down. The negative 90-degree angle, or a 270-degree angle, however you want to think about that. So we've got this 1 amp 90-degree positive phase displacement vector that we're going to add to the inductive vector. It has an impedance of 4055 ohms. So what kind of a current would that allow? Let's see it. 1500 volts, 4055 ohms. 1500 over 4055 comes up with something like 0.3699 amps. It's 0.3699, but remember it's at negative, since it's inductive, right? Negative angles, positive 90 capacitive, negative 90 purely inductive, but this is only 68.29 degrees inductive, so it's coming not horizontal, it's coming down about 68 degrees, and it's only going about 0.3, and I'm not really at a good scale there. So what we're going to come up with is our final vector. Our resultant vector is going to start at the tail of the first, end at the head of the last, and we'll come up with what that final vector magnitude and direction is. So our second vector is 0.3699. At a phase angle of negative 68.29. So how do you find the horizontal and vertical components? Horizontal and vertical components, right? If you just think about a capacitive vector, it's purely up and down. It's zero horizontal. It's purely vertical. You can test it by going length of the vector times the cosine of the angle will give you the horizontal. 1 times cosine 90 equals 0. 1 times sine theta, or 90, equals 1. Right? Why is that? Well, you could go back and review your trigonometry for that. This inductive vector is mainly vertical. It's more than 45 degrees off of horizontal. It's more vertical than horizontal. The vertical component will be greater than the horizontal component. The vertical component is the length of the vector times the sine of the angle. Length of the vector is 0.3699 times the sine of negative, remember your negative sign, is negative 68.29 degrees. Plug that in your calculator. Your vertical component is negative 0.3436. 3437. The vertical component is going to be the length times the cosine of the angle. We expect it to be a little less, and it is. It's 0.1368. You see that? We're going over 0.1368. We're going down 0.3437. And that makes our total inductive vector, this line right in here that I just colored yellow, and I'm highlighting yellow and making it black, that these two horizontal and vertical components add up to that 0.3699. Now it's a matter of adding everything in the vertical column. 1 plus negative 0.3437 equals it's 0.6563. Add everything in the horizontal column, 0.1368. Right, the vertical column, this 6563, we went up 1, we went down 0.3437, so the net vertical is 0.6563. The total horizontal, there was 0 horizontal with capacitive at 0.1368. So what we're just trying to do, that's our resultant triangle right there. We're just trying to figure out what this final hypotenuse is. Knowing vertical and adjacent, we're going to figure out hypotenuse using Pythagorean. It's kind of hard to see there. It's going to be the square root of the vertical component squared plus the horizontal component squared. All right, so we're going to go second square root 0.1368 squared plus 0.6563 squared. You hit enter on your calculator, that closes the parentheses. You'll come up with 0.67, 0.670405. I think that's close enough to 0.67. Right, the length of this red vector here is 0.67, and its net capacitive. It's more capacitive. It's not, it ends up being capacitive with a leading power factor and not inductive. It's 0.67 amps right now. And the phase angle is, let's see, we know the opposite and the adjacent, so you can use the tangent. You go the second tangent of opposite 0.6563 over adjacent 0.1368, we'll get a phase angle. Second tangent 0.6563 divided by 0.1368 equals 78 degrees. 78.17 degrees. 78.17 is capacitive. Right, so now we found the currents with an assumed voltage, we added the currents with vectors. Final step is this. Here's our final step. I'm going to clear a little space, and I'm going to say our final step is going to be impedance is E total over I total. It's going to be 1500, what we assumed, right? So here's where it comes back out of the equation. We don't have to worry about it anymore. And divided by 0.67. So 1500 divided by 0.67 equals, we come up with 2238. 2238 ohms. The phase angle is 78.17. It's capacitive. The power factor is equal to cosine of theta. The cosine of 78.17 is 20% power factor. Okay, 20.5% power factor. So that's the short and skinny, 2 fairly long videos. It's probably almost 30 minutes run time. Hope that isn't too much, but I do believe that should answer most of the questions, and it is certainly a review for the existing students. Might have been a little fast if this is the first time you've thought through it in a while. So good luck. Give me a call if you have any questions.